Steel. It touches our lives every day in the cars that we drive, the buildings we live and work in the appliances, machines, and materials that make our modern lives easier. ArcelorMittal is the premier steel manufacturer and one of the biggest in the USA. But to maintain this critical business, we need to constantly maintain our mills. And now, we're looking for bold, skilled, and knowledgeable individuals to help us do that and carry this key industry into a successful and sustainable future. At ArcelorMittal, our people and their safety is our #1 priority. We conduct pre-job safety meetings. We identify the hazards in the job and put controls in place to maintain safety. These controls are used at all our plants and by all the employees in this video. Employees who work hard every day to maintain the equipment that allows us to produce world-class steel.
Hi, I'm Yolande Sobkowicz, MTM at ArcelorMittal, Indiana Harbor. Every day is different. It's never the same routine over and over usually. So you have something new and challenging every day. We're going to pick this mandrel up and we want it to be level. So we have to do some calculations on how much it weighs. We have to figure out the center of gravity and also figure out what size slings we can use.
Yolande knows that she must first find the volume of the cylinder. The equation for finding the volume is pi times radius squared times length. Once she has calculated the volume, she will multiply that number by the weight of a cubic foot of steel. That will be the rough estimate of how much the mandrel weighs, and then they can select the proper slings to move it. Because this item is not symmetrical, they've also had to calculate the center of gravity in order to know where to place the slings so the mandrel is level.
Just a lift like this, you have to take a lot of things into consideration, like knowing the volume of a cylinder and how to figure that out, or how much a slab would weigh. So we have to do those calculations. If you want a challenging job, this is one under all kinds of conditions, so you've got to be prepared for that.
I'm Repuzynsky. I'm an MTM at ArcelorMittal Cleveland. You need to know that in the classroom. What you're learning now is going to pay dividends once you get out into the mill. Okay, I got a work order today to prepare this shaft for a job out in the mill. Calls for a bearing and a gear coupling to be installed. I'm going to do what we call thermodynamics. The bearing and coupling doesn't fit as it is now, neither one. And it's designed that way. And the only way you can be able to get this on is to use an induction heater, heat it up, and it'll slide on. And when it cools, it'll be a nice snug fit. It's not going to go anywhere.
With his knowledge of thermodynamics, specifically thermal expansion, Rich knows that he can heat the bearing and coupler with induction heating, a process of heating an electrically conducted object, like metal, by electromagnetic induction. This will cause them to expand just enough to install on the shaft and complete the job.
So this is the induction heater. Now the bearing has to heat up to 250 degrees and the gear coupling 350 degrees. Slides on perfect. So now we're going to do the same thing with the gear coupling. Perfect fit. When this cools, it's going to be a snug fit and it's not coming off, trust me.
I'm Jessica Roberts and I'm an MTM at ArcelorMittal Weirton. When you first start out working in a mill like this, it's a little intimidating. Cranes overhead, machines bigger than you could ever imagine. But once you get to know the place and know the people, learn how things work, it's really interesting. And today I'm going to fabricate a machine guard. I'm going to take a look at these blueprints I have here, lay out my lines, get my center, and get all my measurements correct, and then going to cut it.
Jessica will use her knowledge of geometry, trigonometry, and algebra to lay out the lines, angles, and curves for the machine guard.
What my next step would be is to actually make the cut. Another step in fabricating a machine guard is I'm going to have to make a weld. Before I make the weld, I got to determine what materials I need and how to set my machine. So I'm going to do what's called a magnet test.
For Jessica, it's critical to know the type of metal she is working with. ferrous, non-ferrous, or an alloy. That way she knows which welding process to use. In this case, she will use arc welding. Jessica's knowledge of geometry, trigonometry, algebra, and physics is what allows her to fabricate this important machine guard successfully.
You gotta have the skill basis so you can do things accurately. You can't take the time to, do it over and over again.
My name is James Biro, and I'm an MTE at ArcelorMittal Cleveland. My jobs are different every day. I go to different places, different buildings. Every day is a new adventure. This morning, our job was to connect the 3/4 inch rigid conduit from this disconnect switch to the starter for the motor.
To accomplish a project like this, James will be reading blueprints and performing calculations related to Euclidean geometry, specifically the Pythagorean theorem. Trigonometry and algebra will also be used to calculate and measure the length and bends of the conduit.
Now that I've gotten all my measurements and I've got the conduit cut, I'm ready to thread it and bend it to the proper angles that I need to do this job. Now that we've taken our measurements and bent our conduit to the back-to-back 90s, we're going to install it on the disconnect switch and the line starter. Perfect fit. Well, in order to do a job like this, you don't just need luck. You need to know your math. You need to know algebra, a little trigonometry. Without the math, you'll be bending conduit forever and you're never going to get it right.
I'm Pat Marshall. I'm an MTE at ArcelorMittal Weirton. A steel mill like this, it's busy. It's exciting. You see something new all the time. It's a good place to be. What we have is a bad motor on the line. We took it out of service and hopefully get this one, if it tests out, to be okay, put it back in line.
To inspect the motor, Pat will be using a meter to check the voltage and resistance to determine if the current running the motor is correct. Pat will use an electrical principle related to Ohm's law that states voltage, current, and resistance are mathematically as well as physically related to one another.
What we have is a multimeter. It'll check the resistance between the armature leads and the field leads and the motor itself. Okay, that's good. Now let's check A1. And we have 275 million ohms. The rule of thumb is for every volt you have, you want 1,000 ohms of insulation resistance. And being 275 million, that's good. So this checks out, it's in good shape, good to go. You can't just walk in blind and be successful. You have to apply yourself, the fundamentals of math, and you have to be able to communicate with people and understand what's going on in the job.
I'm Luke Smith. I'm an MTE at ArcelorMittal Burns Harbor. I really enjoy being able to work remotely but hands-on at the same time. You can see when you're changing information in the PLC code and things like that. You can see the direct reflection out in the field. I just received a call from senior operator that they had an issue with the chemical feed station on one of the valves. Looking through some of the PLC logic, I can tell that it was an issue with the KM valve.
Luke is working with a programmable logic controller, or PLC, that controls the inputs and outputs for the line to determine the problem. He will review PLC elements like ladder logic and binary code to find the fault. Additionally, Luke has been trained in and/or logic, algebraic expressions of logic relations in digital forms.
I'm able to utilize the PLC to pinpoint exactly what the issue is and then verify it and utilize my operator panel to confirm that. Okay, Jim, I'm going to go ahead and open the valve. Can you verify that it is making the cracks?
Okay, we got the proper action on the position switch.
All right, looks good. We're going to go ahead and try restarting the process. It's very important to try to get these problems solved quickly and as efficiently as possible. Whole systems could be down. You could be stopping a process after this and stopping a process before it and ultimately slowing down production.
I'm Ira Wells, MTE at ArcelorMittal, Indiana Harbor. It makes me feel good to know that the maintenance we perform is very critical because it's all part of a process of producing a quality product. We're inspecting the crane resistance banks, looking for potential hot spots or loose connections. We do this on a weekly basis, and this infrared camera indicates whether or not we have a potential problem. This As a color spectrum here, and the white spot shows the hot spots that we have, maybe a potential problem there.
Finding and fixing potential problems before they become big problems is a critical part of Ira's job as a MTE. Using new technologies helps with that, so it's important that our employees embrace new technology and understand how it works and the theories behind it.
Preventive maintenance is so important. It's all part of that plan of world-class maintenance. Make sure the equipment is running in tip-top shape. It's a challenging job and it's interesting to say the least. And a strong math background, physics and electrical theory helps in performing my job.
Our commitment to the environment is critical to our success as a steel manufacturer and being a good neighbor. We use many systems to remove hazardous materials from the environment. We want the world around us to be as good, if not better, than how we found it. Our future is bright, and with the skills you are learning today, you can join us in transforming tomorrow.
There's so many opportunities coming in as a new person straight out of school.
If you apply yourself, sky's the limit.
We need craftspeople now. We're wanting people that are good in math.
Don't be afraid to get your hands dirty.
Being one of the youngest people in this steel mill, I hope to be here for decades.